I'm Tim Hafner. I'm in the robotics and automation technology major. So here, the original intent was to have two locomotives running on the same track, and that neither one would be able to catch each other because they're not perfect and they're mechanically different. So each locomotive, one's going to be faster than the other. So you have the PLC controlling the locomotives. What happens is I have 4 electrically isolated sections. So there is a plastic joiner here, 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 and here. And so there's a wire going to each one, and there is a resistor, a 10 ohm resistor in series with each block. And the PLC uses analog inputs, and it looks at the voltage across the resistors, and if it senses a voltage, that means the train is present on that track. If there's no voltage, that means there's no current and there's no train on that track. And what it does is it individually will turn off the block behind it. So if I hold this train up right here in this block, as soon as the train enters this block, it will stop that one over there, and it'll no longer be able to run until that one clears the next block. And I thought it would be a little more complex. It actually turned out to be fairly simple as far as programming. So I said I'm going to go a little bit further with it, and I'm going to install a signal system that acts just like the real-world signal system would on the railroad, and it functions better when I run only one. So we'll run one locomotive here, and as you can see, we have a clear signal, and it'll drop to restricting, which is red. And then the same one with this, but if you come back to this signal here, once the train comes around and it'll come in, you go right by this signal, it'll drop to restricting. But after it clears the next signal, this one will go up to approach, which means be prepared to stop at the next signal. So there's your approach, you yellow, and as it goes around, it'll go to the next one. And that's all controlled by the Arduino. So with a common ground, I'm able to read the inputs use the analog inputs to read the voltage of the resistors, and I can sense, and I have 4 variables that are changed by the state of these inputs, and then 4 different functions that go through, and it tells each light what to do based on the state of the variable. So I have each signal has the 3 lights on it, and I have all the wires coming back to here. I'm using 12 different outputs. I'm able to control every single light individually, and I'm able to make these signals change as if it was the real world, and there's the real world railroad circumstances. So.
Okay, cool. All right. Thanks, Tim. Very good.